On this episode of Metal Car Off-Road, I'm going to show you some of the best practices on how to get a good 3D scan. So that way, if you're just getting started with 3D scanning or you've got a 3D scanner and trying to get better scans, this will help you out. So following the last video, I had a handful of viewers reach out and ask some questions regarding 3D scanning. Most of the questions centered around kind of like the basic getting started 3D scanning topics, such as my scans aren't any good, how can I get better scans? What scanner do you use? Like, what was that spray? Why are the lights low? A lot of things centered around like just the basic fundamentals of 3D scan. So I thought, hey, I'll make a video on getting started with 3D scanning, and once I have some parts that I think would be good candidates. Well, as luck would have it, one of my industrial 3D printers self-destructed several months ago, and it's kind of just been sitting in the corner. And I've got an upcoming project for my business that I need that printer to run for because it can print really crazy materials. And I've got two parts that are perfect to be the stars of this video. One is essentially a bracket that holds the heart of the 3D printer, which is the hot end. The hot end, the fans, basically, if you don't know anything about 3D printing, it's the device that melts the plastic, turns it into liquid, and lets the CNC machine do its thing and put it in specific areas. It also holds cooling fans that quickly cool that material to get it back to a solid state. So the printer's dead in the water without it. And I wasn't necessarily happy with the original design of the part, nor was I happy with the material of the part, so I can get a 3D scan of it and make it better in CAD and remanufacture it on one of my own machines with a much better material and better quality part overall. The other part that we have to scan is essentially a cover that covers electronics, and you'll see it has a T0, not a O. That represents the tool head that it goes on, because this machine has two tool heads, and G-code and also the firmware. T0 represents the first tool head. I know it doesn't make any sense. You think it'd start with 1, but starts with 0, and that's pretty much across a ton of different CNC machines that have multiple tools. Anyhow, I'm gonna redo both these parts, but first I have to scan them. Why are they perfect parts to basically feature in this video about 3D scanning? They're small, they do have intricate details, and they also have a lot of perpendicular geometry and 90-degree geometry, so it's very favorable to scan. They're also black. Most scanners, including the one we're going to use today, do not pick up black features very well at all. And there's different reasons for that. We won't worry about that too much right now. These parts also are plastic, and even though they have some kind of, I think they have glass filled in them, they do put off a sheen or a shine. That also is a hard feature of physical parts to pick up by the scanner. There are scanners that are extremely high grade, high precision, high everything, that are designed to like walk over and get a scan of an object no matter what it is. Those two will struggle without some kind of proper approach as far as room lighting, scan spray, the manner of how close you are to the part. And so a lot of what we're going to talk about today also applies to top level scanners as well as like entry level scanners and kind of in between. And so these are good parts to talk about. So those are our parts that are going to be scanned. Oh, there's two broken pieces too that I'm going to gently rest on top of this to get at least a rough enough geometry to build some prototypes to test fit. But we have a turntable. This turntable came with my scanner, and it's just a cheap little turntable with a variable speed that plugs into a kind of external power pack. And we're going to use that because the type of scan we're going to do today is a fixed scan, meaning we're not going to move the scanner around to try to get around the object. We're going to let the object rotate slowly, holding the scanner steady, allowing the scanner to use basically its internal tracking to figure out how that's moving and capture a really good scan. We also have our scan spray that, if you saw the last episode, was what I used to scan the bottom of the seats. This is A-Sub state-of-the-art scanning spray, says it right there. And this is an awesome scanning spray for automotive applications because it will dissipate into the environment. So you can use it on interiors, on engines, on firewalls, on anything you don't want to have to clean up afterwards. This will dissipate. When should you use this scan spray? You should use this scan spray on virtually anything that's got dark features, that has any kind of shine or sheen to it, and honestly, even objects that don't have those two features that can make it harder to scan. Use it on objects that are generally good without it. It helps. It helps increase the scanner's ability to get in there and get features, partially because it does provide some kind of texture feedback, and it also will lighten shadows. So if you've got crevices, like say a red part, those crevices are pretty dark, and the scanner will show kind of gaps, I guess you could call it. Well, the scan spray filling into that area will lighten that up a little bit and enhance those features. At least that's what I found in my experience. So I pretty much will use this on almost everything, unless it is a white part that is completely matte. And then we have our scanner. Our scanner is the same exact scanner that was used in the last video where we made the adapter brackets for the Corbu seats. And it is the Miraco Revopoint. I really like this scanner. As I stated in the previous video, as far as like raw scanning ability, it's okay. It's not the best scanner, but as far as like getting it out of my tool chest, walking over, capturing a scan, it's awesome. It's got an onboard battery, an onboard computer, onboard software. You can flip this screen. So if you're doing like a self scan, you can see where you're scanning because it'll pick up and show the display. I've never used that. I've never scanned anything where I needed to use that feature. It has two separate modes on it. You can go from near to far. There's just lots of reasons why this is a really good tool. And if you're looking into getting into 3D scanning, Revopoint is a really beginner-friendly scanning software, or not software, kind of suite. You get the scanner, you get the scan software, where you kind of import whatever you scanned on this to your computer. You can do some basic editing on it, and then you can get it into some kind of CAD software like Fusion 360, SolidWorks, whatever your preferred CAD is. It's handy. It's also pretty affordable for what it offers. So I think I got this for like 1,300 bucks, which I use it for my business quite a bit too. I've got other scanners that are much more capable than this. However, for car interiors, this is my go-to, and I sell a lot of products with my business that center around car interior features. For any contract work I've done, like this scanner has been really good, especially if it's I got to go on the job site, and this battery lasts several hours when I'm scanning. So I can get a scan on the software, review the scan, and then I'm good to go. So it's been a really good tool. I recommend it. I recommend it for anyone getting into scanning. So that's not a paid endorsement at all by Revopoint. Like, I just like this, and I've had it for a while. So now we've kind of got like the stuff we're going to use to conduct this scan. Let's get our scan going and get started with it. So first thing we're going to do is we're going to get our first part that we want to scan. We're going to hit it with some scan spray. And you'll notice I'm not doing this on my turntable. The reason is my scanner and a lot of other scanners that are out there have a feature that will remove whatever it's scanning on. That's really helpful. So when you go into edit and cut pieces out of this part or do whatever you want, it's one less thing you got to worry about messing with in the software. And so we're just going to hit it with some spray. We've got a lot of crevices on this part. And I did have another can of this just come in. I only keep like one can because it lasts quite a bit. And I can go as heavy on it as I want because I've got another can. Next, we're going to get our turntable set up. And my turntable uses, and you don't need a turntable for this, but a lot of scanners come with turntables, so I thought I'd include that in the video. And my turntable, last time it was used was for a scan, so it should be up at a pretty good speed. When you pick up the part you just sprayed, you can wipe off the scan material, so gently pick it up. Mine turned out pretty good when I picked it up. So now that this part is moving, I'm going to kind of move it back a little bit. We're going to get our scanner. So next step is get the scanner, which I also have a little mini tripod that came with this scanner. You don't need it for this type of scan. You could sit here and hold steadily, but I've found that having the scanner totally static in a fixed position greatly helps with its ability to track, especially on some like consumer scanners that are more commonly going into garages right now. And so we're going to use our little tripod because we have it. So I'm getting my scanner set up, and if you've got a scanner with multiple scan features, for example, this scanner can do what's called a far scan or a near scan. Far scan would be good for like scanning a whole interior or even a whole vehicle, really big components. A near scan is going to provide a more precise reading and is much better for small parts with intricate features. So I usually use mine on far scan because I'm doing a lot of big objects. Like the seat brackets I just made, I use the far scan to get all the features of the mounting locations for the factory brackets and also the new aftermarket Corbu seats that were going on them. So I've got my scanner in near mode, and now what I'm going to do is I'm going to get this in an appropriate distance away and also a good angle, so that way it's getting a really good reading of this. And most scanners have multiple optics or multiple sensors that are actually firing a laser and getting a reading. And so oftentimes there will be essentially a gauge on the side that's almost like a sight picture that shows you whether or not your center mass on the object that you're trying to get a good scan of and you're hitting the feature you're supposed to. And so in this case, mine has them on the side. So I'm using those to basically get this object as it rotates through. And my reading of this right now is pretty good, but essentially my gauge bar that says whether it's a really good scan or not, which is optimal for really good tracking, all kinds of other features, is saying that I'm a little too close. So this is where it's pretty critical. So like scanning is a lot like painting a vehicle. It's all in the prep. Getting everything set up, getting a nice orientation is really key to making any scanner work good. And I've used some really, really bad scanners that I've gotten good scans out of. You just had to work really hard to get them. On the flip side, I've seen people use really good scanners and not put a lot of prep work into them and not gotten good scans and charge people a lot of money for them. Like that's, I can't stress enough, the prep for getting a scan is really what makes a good scan. Machine helps a lot of the part, how easy or hard the part is, that also is obviously a contributing factor, but I don't know. So we are set up with a quality scan, setup, distance, location, orientation. So before we start scanning, we're going to dim the lights. So we've dimmed the lights that are directly overhead. The reason that I do that with scans, especially for objects that you do have scan spray on, is that you've got a better chance to create any kind of reflection off the part you're scanning, which can throw the tracking off on the scanner. It can also create some negative spaces in the scan itself because as the scanner tries to read that light's already reflecting off of it, and the way the lasers will hit that or the optics will pick it up is not favorable. So no light is not good. A ton of light is not good. You really just need to have like a dim light and no direct lighting hitting it. And there are some scanners out there that can react really well with light. A lot of those are pretty expensive. This scanner does pretty good with light, but I've still gotten better scans with dim light. So dim light is definitely a helpful tip for getting a good scan. We've got everything ready. We're going to commence our scan. We are scanning. What we're looking for in the scan is the ability for the scanner to pick up all the details while continuously tracking. Our turntable speed really dictates the ability to tracking, the ability to track combined with the specific features of the part. For example, a really complicated part with tons of funky asymmetrical geometries would make really hard scanning, especially even rotating. This part being boxy, perpendicular with different angles and pretty small is allowing for it to pick up really good features and get a really good scan. And I'm just watching on the scanner to make sure that we're not creating any duplications of the part, like any kind of weird floating objects hanging off the part. And I can see a frame count. That frame count is going to really come into play when you put this into any kind of software and you build out the final part. It's like a recipe for the software to generate a finished product and to kind of guess where maybe some geometry was off in the scan and counter that, especially if you've got mirrored components on the part, i.e. On this case, there's a fan housing on one side. There normally is a fan housing on the other. If that other fan housing was there, it could pick that up and basically figure out like where it needs to counter and put it in there. So there's not a specific like best practice amount of frames, but I think several hundred frames on a smaller part's usually pretty adequate. I'm already up to 1,100 frames. I'm going to stop it. Like that's pretty good. And now that I've got a really good scan of this part, what I'm going to do is I'm going to review it in the scanner. If you have a scanner that requires a computer, which is pretty common still for a lot of scanners, then you can do the same thing probably in whatever software you're using. And most of the times, if you're not happy with the part, it looks pretty good, but it's missing some features, you can come right back over and continue scanning. And for the most part, it's not true with all scanners, the scanners will pick up the geometry where you left off in tracking, especially if it's got some specific features of the part. And so I'm looking right now and I think it's a pretty good scan. I'm really looking at my broken parts of the scan to see how they are. I'm going to check the box, which takes me into a different model of the scan. And when you're viewing this on the scanner or on the software in its raw scan, there will be some almost transparent features on the scan. That is where having the higher frame count and a more accurate scan comes into play, because it'll go through, the computer will go through whatever you're editing in and try to guess where those other features are. Plus, if you're manually editing it, you can pick up enough of the feature that's there, which will more likely be denser with higher frames, and reconstruct the part in CAD. I'm pretty happy with my scanned part. I think I'm going to move forward. And for this part, we're actually a little too high or too close. But I'm going to roll with it. All you have to do if you're a little too close is back up some. The scanner says that this positioning is excellent, and so we're going to roll with it. I'm going to move that out of the way. And same exact thing as before, we've got a pretty basic shape with basic geometry that we're going to get like roughly a 500 frame count scan on. And letting this thing build its geometry. Tracking is trying to figure out where to put everything right now using lasers. I really just want the shell, the outer dimensions of everything and the tabs. So I think I can't stress enough when you have a part you want to scan, back plan off of what you plan on doing to the scan once you get it. So, or why you want the scan. So if you have a part you want to replicate, get a ton of really good scans from different sides, different angles. If you just want basic geometry, get in, get a quick scan and get out. Like it's basic geometry, like hole location, especially if it's got high tolerances, like the C brackets I scan, then you don't need to have a million scans of some simple bracket layout, especially if it's a flat component. And if you can get like hand measurements just to verify the data you do have, that's even better. I try to do that with as much as I can, whether it's with calipers or measuring tape. But yeah, this is coming out pretty good. All right, we've got our scans. That's all there is to it. I think, like I said, a couple takeaways for this: prepping the scan is key to getting a good scan, no matter the device you're using. Understanding how you have to prep. In this case, scan spray to remove any kind of gloss, any kind of sheen, to lighten any dark features in the object, or if it's just a black part, to allow the scanner to read a lot better. Also, having a game plan for what you want to do with the scan once you get it, so you can back plan off that, so you understand how many scans to acquire, how long to scan, how many frames to get. That way, you're not having to come back out and get more scans. That is something I found that is super annoying when you've got 75% of the part in CAD, ready to go, and you're like, man, I missed a feature. And so taking your time with it, kind of dedicating a specific time slot to get the scan done, following all those prep steps will really help you get a good scan. So I hope this is helpful to anybody getting into scanning, looking into getting into scanners. If you have any questions, drop a comment. I'll share some of my experiences as well as provide you with as much information as possible. The Miraco Revopoint scanner is really good in an automotive shop environment because of the ability to pick it up, go, get a scan. It's pretty durable. I don't know what its IP rating is, but I'm pretty sure it has some kind of IP rating. Definitely don't want to get it nasty, but I think it would wipe off pretty good if you did with some basic multi-surface type cleaner. But it's handy because there's no computers, not wires. It's got a rechargeable battery. Right now, it's not even plugged in. Battery's at 70%, and it's been scanning and recording a screen the whole entire time. It can do multiple features, so it's a good starting point if you're looking into getting into scanning. I think they've even got some new and improved versions of it out now, because this scanner, I think, is like a year old, year and a half old. And the tech grows so fast that a lot of the manufacturers will have a new version out 6 months later. So who knows what's out there now. But I hope that you found this helpful. I hope it helps you. Taking the time to learn this new technology and get it into your shop can help you out with projects, can help you out with your business. There's lots of ways that a 3D scanner could benefit you, especially if you're working with CNC type manufacturing methods already. Scanner kind of brings that into the fold and enables you to make more stuff. So I've got a lot planned. I've got a series planned on 3D scanning that I'll continue on with basic software editing and best practices for getting parts replicated in Fusion and working with designs. So like, follow, subscribe, all those great YouTuber things, so you can stay tuned and see what's up next. Thanks for watching. I'll see you next time.